Hello everyone and welcome back at CodingBulls. Today we will continue our competitive programming tutorial series and we will take a look into a codeforces contest that's about to begin. First, I prepared 6 files. All of them contains this basic code, which basically just use this type depth as long and LD as long double, and we will have this IO spacing to test it here first, and then we will solve some test cases. And we will use this solve function to solve all the problems. And I made 6 copies for 6 problems. Let's open up codeforces, and we can see that we still have 1.5 minutes until the contest starts. So until then, I will explain this code. If you follow this series, you already know how it works. We have this basic pre-written code that we will use to solve these problems. Now I use a shorter version. In a later video I will show you my pre-written code template that I use in most codeforces rounds. So we will have one test case and we will take it from the input, and then if the test case is positive, then we will solve the test case and we will write the code here. If there are no more test cases in a single test case, then we will just remove this line of code, so that way it will be so much faster. And I will put my cursor here because most likely I will start coding here, and we still have 36 seconds. Another good idea is have these basic variable names already assigned, because most likely we will have a name variable named n, and if not, then we just won't use it. So when the contest begins, I will start with the easiest problem and work my way to the hardest problem. I feel like that's the way to do most of the contest, but if we are stuck in a problem, then we might go and take a look at the next problem and come back later. So the contest is about to begin, so you can enter the contest. So in this problem, we just need to count the unique strings or unique two cluster substrings in a string. So we will have a number, the length of the string as an input, then we will have a string, and then we will input the string, and here I go I plus 1 less than s.size, or you can use n as well. And I will have a set where I insert so I will just use the s.substring function where I will put the starting character and the size, and this will be a string, and then I will output the size of this string. Now I will take a look if it's allowed to have a string with one length. Luckily it's not, so we don't need to worry about it. So repeat and run it. Copy the input, we paste it. See that we had the correct output, so we go ahead and upload the solution. And then submit it. So this was the problem. We just needed to take a look at the unique substrings, and I used the set because the set can only contain the same string one at a time, and we got accepted. So we will go back to the problems and continue with problem B. So let's do the problem. Okay, so in this problem we will have two arrays. We will have an K and the array A and the array B. So we will have an K, then we will take them from the input, and then we will have an array A and an array B, or we can use a vector. In this case I will use a vector. And show to code them A and B. And then both of them will be a length of n. First we will have the array A, and then we will have the B, and we will use them as a vector. So what we know is that they are between 10 to the power of 9, positive or negative, and K is also that, and the array B is mixed up, and we need to find the correct way where A I and B I doesn't differ by more than K in many cases. And then we need to output the array. So for that we will use a greedy method. First, actually, I will replace this as a pair, and I will store the index. The reason for this is after that I want to sort the values. And for the array A, I want to make sure that the program remembers where that value was. So now we can go ahead and put the lowest value to the lowest, and then we will go on. If there exists a solution, this will give us the solution. So the reason for this is pretty easy to see, because if we have the lowest value, then we want to add the lowest value possible, and if the lowest value from B cannot be assigned to that means that that lowest value from B cannot be assigned to any of the A values, therefore there doesn't exist a solution. So if a solution exists, then this is a correct solution, and we got guaranteed the solution exists. So now we need to store that we need the BI to be equal as the AI.second element. So for that we will just say that answer AI.second, this element needs to be equal to BI, And for that, we will have a vector long answer, and we resize it to n of length. And then we go ahead and output this answer vector, and then we don't forget to add a new line. Now we can work with a line. If I remember correctly, we had more test cases. Yes, we did. So we can copy the code and then insert it, and then we got a solution. Of course, we don't want to check if it's correct or not. We will just upload it, because there might be multiple correct solutions. So if our solution is not exactly like the output solution, that still can mean that it's correct. So we will just submit it and see what the result is. If codeforces is slow, then we need to use m2.codeforces.com or m1 or m3. I will refresh this page to see if our solution got submitted or not. This is sometimes a bit annoying, because if you resubmit it and your solution was correct, then you still get points deducted. So it seems to work now, so I will just stick to the main site and submit it. And it's running. Test cases. And if it takes too long to run, we can just go ahead and start reading the problem, or at least open it. Then we can come back and refresh it, and it's accepted, so we can go on to the first problem. So in this problem, we just need to output if a solution exists or not, and we will have this array. And do we have multiple test cases? Yes, we do. So we'll take the n, and I will use a vector because I don't know what I want to do with it yet. And then we will have that, and we will take the input. And as you can see, this is like takes a few seconds of coding. So if you want to make it faster, then you can have templates which can do these basic inputs. I will show an example for that in the next video, but now let's focus on the task. So I got this array v, and we need to determine if the transfer exists or not. So what I also like to do is have a string called yes, which will be yes and a new line, and a string called no, which will be no and a new line, and we will just output it when we know the answer. So let's see. We need to build an array b, and we can assign each value bi either to the value ai or ai minus aj, but we can choose any of these numbers. Of course, we can choose the same because it needs to be positive, so it can be c. So what we know, if we have the one of the lowest values from the a, then it can be deducted from, and we can deduct anything from it because we can see that they are positive, so it would be negative or 0, which is not allowed. So we need to select the lowest value, and we will get the parity based on that. Also, the order doesn't matter, we just want to know if it's possible to sort it or not. So I will just sort it, and now we know that v0 is the parity because that's the lowest value and we can't deduct anything from it. with staying above 0, so that will be our parity. And now we'll go through from 1 until the dot size, which is n. We can use either of these, and we will go through, and if vi divided by the modulo by 2 is not equal with the 0 of modulo by 2, then we will need to deduct something in order to solve it. If it's the same, then we don't have to deduct it, it's fine. If it's not the same, then we need to make sure that we need to deduct something to make it the same. That means that we need, because it's not the same and it's just the parity, we need to deduct something odd. So if we have odd, which is lower than this, then we are fine. But if we don't have odd, then we will have the OK set to false, and we will have this bool OK, which will store if our solution is good. First we assume it's good, and if we find something that we can do, then we will take it false, and we will break out. It's optional, but I like to break out because we just do it. And if OK, then we will output yes, otherwise we will output no. And remember, these also have the new line character, and we need this. We have odd, which is normally false, and now we just need to see if we have an odd character. So, but it also needs to be lower. So if this is even, then for the first odd character we get, it will ruin. It will make sure that we can solve the problem. So in this case, it doesn't matter if we store this. The first odd will be definitely bad. But if this is odd, then if the next one is even, then we can deduct it because it can't be equal. So the only way this will be a problem is actually if vi is even. So once again, the reason for this is if, sorry, b0. So reason for this, if we started with odd, then after, if we get odd, then we will keep it, and if we get even, we will deduct v0 from it. So it's fine. If we started from, it will always be fine because odd can be equal to even, therefore all of them will be higher. If we started with odd, then as long as we get odds, it's fine, and when we get even, then we can deduct it. If we start with even and we get an odd, we can't deduct anything else because that's lowest odd, so it's bad. So we can actually remove this, and just to make it better. Of course, if you are doing it by the contest, you shouldn't make these modifications because it just takes time. But this code will be a bit more efficient like this. So we only need to go through this if it was even, because if it's odd, then we are all right. And then just copy and forgot to declare the n variable. Then we will paste. Copy the code. No, yes, no. From the no, yes, no. Cool. So we can go ahead and submit it. This was number 3. We submit it. And now it's running, we can open up the first problem. Point Chrome 2, and we can come back and refresh it, and it's accepted. So let's see. Yeah. So we need to apply this operation exactly as we choose a segment, and then we can reverse it, and then we set the prefix and suffix of it. And exactly as means that we are forced to make this operation even if we don't want to. And we need to output the lexicography maximum permutation. And you can see the definition of it, and we also have test cases. So we will first take the input. Even if you don't know the solution, you have no idea how to solve it. First take the input, and then you can see it slightly better. I also like to call the vectors v every time, regardless of what we call it on the problem statement. And actually we can come back and copy this code. Alright, so and then doesn't exceed 2000. That means that we can have a solution which runtime is n to the power of 2. That's fine in this example. So we need to think up of a solution, and for if we want to make the lexicography maximum permutation, that means that first we want to maximize the first character, and then the second, and then the third, and then so on. So our task is to get the largest character in the beginning. That's the first step, and we need to go from there. Because this is a permutation, it's also good to have this var vector, and what we will do is resize it to n, and then we will store here that the value, this value is at the position I in this v vector. That means that we can find these values more easily. So the values will go from 1 to n, and the positions from 0 to n minus 1, so be careful with that. And that means that we want to use the var n, because these values go from 1 to n and not 1 to n minus 1, so we will make sure that the values go from 0 to n minus 1 as well. And I will actually push back the value the minus 1 here, because in this case we can modify them, because our choice of this segment won't affect if we deduct 1 from everything. It doesn't affect the lexicographical order. And now we need to output the maximum permutation, so we need to remember to add 1 back up. So we need to use where this largest element is, because we want to make sure that this is on the top. The first element, that's our first goal. If we can achieve it, we must achieve it. So we need to take a look at this. How can we make it to the top? So if it's not the first element yet, then we need to make sure that our segment that we choose ends right before it. Because that way, when we swap the prefix and suffix, this suffix first character will be the first character of this. And if it's the first element, then because we get the element to the first place, which will be the first element of the suffix. That means that we can't achieve it. So if it's the first, then we can only put the second there because we are forced to take an operation. So any operation we take, because r is larger than or equal to l, we'll make this change. I'm thinking if we choose the whole array, then it will still remove that character. Yeah, so it will always remove it, no matter what we do. Even if we choose something like this, we will reverse it, and even though the suffix is empty, it can be empty, we will swap this empty to this too. So just thinking something like this, so the largest element is first, then we have this, and if it's possible to keep this at front with an operation, but no, if we choose everything, and then this last element will be first. If we choose something between, then we will put this here. If we choose something that starts in the beginning, then we will still have this one in the beginning, and if we choose something that ends at the segment, then we will swap it, and the last element that we choose will be the first. Because we will put this here and reverse it, so it's not possible. So in that case, we need the n-2 to be there. So if where n-1 equals null, which is the first position, then we can't put this at the first spot, otherwise we can. So now we have two lines. So otherwise, how can we put this at the first spot if we have something like this? So actually we have one more special case that we need to cover. If it's the last. If it's the last, then if we choose, if our segment will end here in the 2, then this will be the first character. And also, if our segment ends in 5, then after we reverse it, it will be here, so it will also be there. So that's our two options here. So I will check if where n-1 is equal n-1. If it's in the end, then we can end our segment at the last element. Otherwise, we need to end. Oh, and also we can always end at the element before it. So we will have an answer and here in the beginning the answer will be the something that's always, let's say 0, always lower because we want the maximum. So and we will have a function here after making a move where we will have the right and we will return the vector. So the way it works, first we will have the suffix, and I will take this and as a global variable because I forgot to take this. So first we have the suffix, and also need the b to be global to be easier, and therefore before we do anything we clear the b vector because we have multiple test cases. Okay, and then we will have this interval reversed, so we will go from R and y it's greater or equal to 12 and we go minus, then we will push back vi, and then finally we will have the prefix, so we will go from 0 until less than L, and then we will push back vi and return answer, and then we will have another function should return the maximum of these vectors. So we go for the size, and if AI is greater than BI, then we will return A. Actually, we don't need this, as if BI is greater than AI, we will return B. Otherwise, we will keep going, and if they are equal, then we will return A. Of course, if the size wasn't the same, then we would need to check which size is bigger, but we know that it's always the same, so it doesn't matter in this case. So we have this answer here, and so we know in this case that in this segment R we always need it to be equal to be var n minus 1, or if this is the case, then R can be equal to n minus 1. So what we will do is we will have the L go from until it's R, and increase it, and we can fix the R as var n minus 1 minus 1. So here we will make the answer be equal the maximum vector of answer and the vector after this move. So that way we will store the maximum. Of course, if you take this by reference, it will be faster, but in this case the solution with the time limit of n to the power of 2 will be good, so you don't have to worry about it. So now, if this is the case, then we will fix the R to be equal, actually this will be n minus 1 this time, and we can go through this again. And otherwise, here we will do the same, but with n minus 2 here instead. Now we will just go through the answer and output it. And one more thing is because we assumed in this solution that there are at least 2 numbers in the vector, we need to check the input, and we can see that n can be 1. So here, after we take the input, if there are more test cases, make sure to take the input even if you already know the answer. So here you will know the answer after you see that the size is 1, but you actually want to read that value, which will be 1 obviously, just because you want to make sure that your input is clean. So if n is equal 1, then you will output 1, because that will be the number, and then a new line, and then we will return from this solve function. And we also shouldn't forget that we need to add 1 because we deducted 1 in the beginning. So if we go a bit underneath, look at this code, and this. So now it's hard to see if the solution is correct, but I will just check a few examples. Yeah, this seems correct. This seems correct as well. So if you go ahead and submit it, remember there is no time penalty if your solution fails on the first test case. So feel free to submit it if you don't want to see, and we can see that our solution is correct. So now we can go ahead and capital 3. By the way, you can see the number of people who solved a certain problem here so far in the contest. So let's read the next problem. So this seems like an interesting problem. So do we have more test cases? We do. So we will have n people, and we will also have an array. So I will use vector here. Okay, and this vector contains one of the neighbors that I remember, and we need to output the minimum and the maximum number of cycles that it can be. So they are assigned to different round dances, and they will dance, and there are at least two people in each round, and everyone remembers one of its neighbors, but everyone has two neighbors, and we need to output the minimum maximum possible value. So if n is 2, then we actually know that there will be at least 1 and at most 1 round dances. That's a pretty easy example. And if n is 3, then we know that actually that will be the same, because we can't split them in two ways. So we will just output that, so we get rid of some of the edge cases that might cause some problems. And now we need to think about the larger solutions. So for this, we will actually use a graph. So we will have edges, which will be capital N, and we will have the max size capital N equal to the number of people to the power of 5 plus 1. Okay, and before we start anything, we will go ahead and erase all of these edges that we had from previous solves, because we have more test cases. Alright, and then here we will index it from 1 to n, and we will solve it in a way of graphs. So that means that E1, Vi, has a neighbor which is var, and var has a neighbor which is I. Right? And actually I will use set because I don't want to input the same people over and over again. But if I use set, I can't refer to a certain character. So yeah, that's fine actually, because there can only be 2 people in this set. So we can do that. Okay, and then then these will only contain the same person once, and everyone has at most 2 neighbors. So someone might have 1 neighbor, someone might have 2 fixed neighbors. So we go from 1 to n and cut DFS from that position, which we will define in a moment. So the way this will look is we will have used. Here we will set to used. Okay, and we set used I to be true, and for auto yes on e I, please, sorry, if not used. If we haven't used s, then we will do DFS s. Okay. And there are 2 ways this DFS can end. Either we went a full cycle and we got back to the first person, and therefore that's just 1 cycle that's fixed, or we went on the road and we don't have the fixed neighbor for the next person. That means that for those roads we can actually go back to the first person or put another road in it. So they can increase the value, but they don't have to. The cycles has to increase the value. So we will have must and optional, and we will set them to 0. And every time we do this, if it's a road, then we will increase the optional, otherwise we will increase the must. And of course from the optionals, we need the solution will be at least 1 when we put everyone together, and at most the number of options. Therefore, in the end, we will output for the minimum the must plus 1, because we need to take 1 from the optionals. Actually, must, and 1 if the optional is not 0. So I will call it additional must equals 0, and if optional is greater than 0, then this additional must should be 1, and then we will output the must plus additional must, that's the minimum, and then we will output the space, and then we will output the must plus optional, and then we will output a new line, and that will be our solution. Now we just need to check how it ends, if we went a cycle or we did not go a cycle. So for that we need to check when we go a cycle and when we don't go a cycle. So if we went a cycle, that means that everyone has 2 fixed neighbors inside, because if someone had only 1 fixed neighbor, that means that we went a road. So we will have a pool which will be this cycle, which is true in the beginning, and make sure that before every DFS we set it back to true. And here, if easy dot size is less than 2 or not 2, then the cycle will be false, because we can't have a cycle if one of them has only 1 neighbor. Of course, everyone has at least one neighbor because they remember one. So that means that the cycle will be false. We won't have a cycle. Except if there are only 2 people, because then we don't count the same neighbor ones. We need to check that case as well. So we will actually return the number of people that we reached. So to check that case, actually just set it at 1 because we already did this one, and here I will just increase it by this. So we set a default, we set a return value of this, and here if so here I will have number of people equal to this, and if number of people is at least 2, or if it's 2, or if cycle is true, then we have a cycle. That means that we will increase the must, otherwise we will increase the optional. That should be it. So let's go and read that on it. Copy this code. Sorry, it should be C here. Paste it. And did I the most optional set that to 0? The use is cleared. Oh, and I forgot that here we will only go through it if we haven't used it. So if we used it, then we will just continue to the next iteration. So now we can go a bit and run it again and check out solution. So 1 1. Not correct. So let's think about the problem. So so the problem here is if there are 2 people, then they can still be considered as optional because they don't have to be next to each other twice. So I will go ahead and delete this. So we don't need the number of people. Just my mistake. So we just need this. If the size is less than 2, then it's not cycle. And here also, if used I, then we will continue, and if cycle, then we will increase the must, otherwise we will increase the optional. Okay, so let's go a bit at it again. Copy code, the input. Okay, see here, and here this cycle. So we test it, and we can see that it should be correct here. Seems right. So we will go ahead and submit it. This was the 5th problem. And now we can see if it's correct or not. Compilation error. So options and just here this. So here which option variable is opt, and see if I just name something the same name as it's included in title library. So of course computational doesn't cost us any point deduction. So let's go ahead and try to submit it again with different name. Seems like we got a wrong answer here for the fifth test case. Yeah, so it's my bad, I forgot to actually return here because we outputted the solution twice in this case. So we will output the solution to the next test case. So make sure to always return if you output the solution. So here is this return. So let's see, and now we got accepted. So we can go back and continue with the next problem. So the first instruction is that it will be a 2-pointer, so we will have the non-longs mod set as 1 E9 plus 7, yes, and then we will have and then we will take inputs. So we need m tensors, and their double difference has to be most m as well. So we only need the number of these bases. Let's go ahead and copy this code. So we will sort the values because we don't care what order we got it in. Okay, so strict less than m. That means that the only codetenses are people who have the tens levels of x, x plus 1, x plus 2, and so on until x plus m minus 1. These are the only codetenses that we can have. So what we will do is actually not a 2-pointer problem anymore. So we go through the v. Again, you can use v.size of n because you know the size already. And we will have a map here which will contain k as long and the value as long, and we call it ma. So we will increase ma pi by 1. Remember, if you haven't touched it, it will be default value as 0. So make sure to declare it here because after you are done, it will be deleted, and this next iteration, when you solve it again, will be another. Okay, if you declare it outside, then you would need to clear the values every time you're done. So we will increase that value, and then now we will we will go through this MA map. The way it will go through any values that you already used. So in this example, we will only go through the values of VI because the map can't contain anything as well. So it won't touch anything that you haven't modified yet. So what we will do is we will have long look here, which will be, we will have a long look outside, and so which will be 0, and tire should be 1 by default. This will count how many possibilities we have, and we will go while and we check if m equal 1 is allowed. Unfortunately it is, so we will need to check that differently. So while, so this s02 will be actually a pair, it will have the value and the key. So the key will be s dot first, and the var will be s dot second. Actually, the mode will be equal to value in the beginning. So while, and if value is 0, then we will continue because we only care about the options when we have that type of level. Of course, a level can be more than 1. So while MA k plus I plus 1 is larger than 0. So we have an I here, which will start at 0. Then we will increase I, and we will multiply the value by this value, and if so, we will multiply it by the number of options that we have here. So if there is a level 5 tensors, there are 5 of them, then we have 5 options to take them, and of course they have to be distinct, so we can only pick 5 of them, and we will therefore make something that starts here and we will go here. So we will go through these options, and if one of them is 0, then we can't have the solution, so we will just continue to the next value, which is larger. And we will also, here after using it, we will reset the value. So a key, set it to 0, meaning that we already checked this and we don't need to check it again after the next iteration. So make sure it's 0, and we can actually have this down here, because if it's 0, then we don't have to put it at 0 again. So, and now we need to do operations modulo something, and if this, and if, so remember that we increase this I only after, or actually we can increase it before, and now we can refer it like this. And now the number of elements, so we will say that this is the last element, the k plus I. That means that we need it to start it at k plus I, and we will need to deduct m minus 1. if k plus I minus m minus 1 is at least k, so we started at least there, but if it's higher, then our answer will be less equal to mod. Now, of course, because we take modular operations, we need to make sure that they are actually modular operations. And for that, we'll actually use one of my template codes. You can see these are my templates that I use for the programming competitions. We'll go through them in a future video. All of them are written by me, by the way. And I have this co-class that can do operations with modulo. So I will just use this, and I need to do up here. Actually, it's already set to the correct value. So it's called mod LL, and the way it works is simply makes all the operations modulo. So in our future videos, I will show you how it works and how to use it. So right now I will just switch these to mod LL, and so they will count it properly based on the modulo. So, but also, if this one less element is greater than k, then we will need to divide our multiplier by the multiplier here. So I will have, so we would need to do this, but they are already set back to the value. Therefore I will use another map, which will be B, and this is the same map, but I don't put the values back. So just exact same map, don't put the values back, and then I can divide back, because we no longer can select a tensor with that level. So we can only select from this range, from here until, so from here to here, or so from here to here. So for the lower values, we always need to divide back. Now we can increase the values and increase the answer, and we will print it to the new line. This is the function I have for printing the value. And there's one more thing about if the m is equal 1. So if it's 1, I will actually make it separately. If m is 1, then we can select any tensor and it will be fine. So we will just need to output the number of tensors. Of course, modulo the mod, that it will be way smaller, so it doesn't matter. And we don't forget to return. So now we can go and build on it. And take the input. So it was always 0, it seems. So let's see. I mess something up. Oh yeah, of course. So I need to write this after this line. Otherwise I will just multiply by 0. So now we got a wrong output answer. So you can see that the second stage that starts here, we outputted 1, but we should have outputted 2, I believe. Yes, it was 2. So we rejected input. So yeah, you can see that 2, 2, 3, 4, 6 should be 2. So we need to check where we messed it up. Oh, yeah, so at here, this will, so I meant if it's like a lower value, so this is the first value that's inside, and I wanted to divide by the multiplier of the value before this. So the value right before this value, so which is 1 smaller than this, but this is actually 1 higher, so this will be the correct one. And oh, and here as well, like this. Need to divide by that value. So I divided by one value. So now if we go and test it, we can see that we should have, yes, seemingly the correct solutions. So we go ahead and submit it. This will be the 6th problem. And thank you. So we adjust. Right. And we got a wrong answer on test case 4, which is interesting. So now we have a wrong answer, but we don't know the test case for the wrong answer, so we need to check our code first. Let's see if n is 1, then we output it n, because there can be n different, and then we returned as well. Did we have a test case here where n was 1? Yes, we had. We output it correctly, okay. So now we take a look what else can be the problems. Sorted them. Yes. We set these correctly. Okay. Okay, and we also set the values. So if m is 1, then we already returned them. So indeed here in our operation we check if these are the scale levels, and then we keep track of the multiplier of how many times we can, how many different ways we can choose that. So we will divide back by this the people, and we need 3 value, and the values will be 1 1 2 2 3 3 4 4 and 5 5. That's the people. So it says 24. Let's check it. So we can have 1 from 1 to 3, 1 from these 2 3 4, and 3 4 5. So that's 3 times 8, maybe. So which is correct. Let's see. We have 10, 2, 7 1 1, 2, 3 3 3 3, 4 4, 6 15. So if you have the 1 2, that's 3. If you have the 2 and 3, that's 4. That's 7. If we have the 3 and 4, that's 8. Yeah, that seems correct. Not sure what the issue is. So right now I can't figure out the issue, so let's go ahead and solve the next problem, and we can come back this to later. So we also have multiple test cases in this one, and here we will have an n, and then we will have 3. So we will have a minus 1 vertices and a minus 1 edges. So we had graph here. So I will do is go from -1 and take the input and maybe I have this if I remember correctly. Yeah, it was the maximum. We also need to make sure to clear the previous values. Like this. Here we will push back the values. This, okay. And then, of course, because we want branches, if n is not divisible by 3, then we will output -1 and the new line and return, because we can't make the branches that way, because all branches need to be 3 nodes. So we will also have parent, which is the parent, and we will also have the DFS function, and we will have to see, and we will also have used array as usual, and we set the used C as true here, and here we will reset these values. Okay, and if not used s, then we will set the parent of s to be equal to c, and then we will do the DFS from s like this. We have the DFS function. So here we will DFS 1. Okay, and we can store the parents. I need to think about the solution. So here sorry, I will open a pen so I can draw while you can follow the drawing. So we have a tree. We have the address here. So we have nodes and edges in the moment. So let's say it's something like this. Okay. We will have back here. So these are the leaves that doesn't have anything coming down. So we will have this leaf, and we will have those default values here as true. And here, if they have some bun, who they are parent, then we will have this leaf as for instance. But actually, I will count the childs instead. And then if childs is 0, then it's a leaf. So childs C will be increased, the number of childs. we can have child count. Let me just add the child. Okay. Tier childs I should be 0. Okay. So to the drawing. So for these leaves that doesn't have any child, it's pretty simple because the only way they can be in a branch is with one of the parents, and the parents should take the other child. If they don't have, or their parent. So if we can see right ahead, if let's say that there are 3 leaves here, so if we have an extra leaf here, that means that it's impossible to do it, because every leaf needs to have its parent as one of the branches with itself, but 3 of them can't have them, so only 2. So in this case, they have to be in one branch, they have to be in one branch, and then we will have them in one branch too. So in this way it's solvable, but for every leaf we know that they need to have the parent with themselves. If there is a leaf with only, and its parent has only one child, which is them, then we can have the branch with the leaf, the parent, and the parent's parent. That's also possible, but if they have 2 childs, then we need that. So what we will do here is go through all of them, and if childs I 0, then shall we just q.push I, and then I will have this q declared. So I will put them in a queue, and I will assume that we have a good setup, and right, it's not empty. Of course, if n is 3, then we don't need to cut anything. Then we will see our output 0 in the new line, and we don't need to output anything for the new line, so we put the new line again. We will return, otherwise we will need cuts. So we will also have a vector of cuts, and we need to cut the edges. That means that here actually, unfortunately, we need sorry, not there. Here we need a pair, and we will also need to store the ID of it. It should be +1. That means that we need a pair here just to store the and here we need the s.first, s.first, and we will also store the ID of that. So maybe store the ID for the edge that leads to the parent. That way we know the IDs. Alright, so back here. So by q is not empty, we will have a value q.front, and then we will pop it. Alright, and here, of course, here we will go, and so let's just call it A, and B will be the parent of A, and if, of course, child b is larger than 2, then OK will be false because we can't have more than 2 childs of it as active child, as we explained before. Otherwise, if, and by the way, I'm counting the active childs here, so I will update the childs count. If childs is 2, then auto s e, and we go through all of the neighbors, and if that we have a used b here as well for just another used array. These are set to false, and here the used will be done in a way, so the used b, that we already have a branch for it. So the first one was only for the DFS, the second one we build for the branches. So we go through them. We check how much time we have. We have so this 3 minutes for the contest. So if then we haven't used it, so we s and parent s is equal to c. So sorry, b. So we are not that way around. We are not going for the parent. Then c should be equal to, oh, and it's so s is not a, then c should be equal to s. Okay, so we will have a c. Okay, s, otherwise c should be equal to parent of b. So otherwise we take the parent. Okay, and now we will set the used b, c as true, and we will also decrease the number of childs of the parents of a and b and c. And where do we need to cut? If it was 2 childs and the parent, so this is the true 2-child version, then we need to cut here. So we need to cut above. So if we had 2 childs and the parent here, then and we are currently not at the root of the tree, is 1. So if b is not equal to 1, then we had to cut, and the cut was, where was the cut? It was to the parents cut, and we stored this PID. So we will have this PID of the P. This is the parent, and that had to cut up above that. Otherwise, if we had the way when we have these way of cutting, when we have the parent, the child, the parent, and the parent's parent, then we had to cut the one above the parent. So then we had to cat here. So otherwise C will be the parent of B, and if C is not equal to 1, which is the root of the tree, then we will cats dot push back. That will push back the parent of the C, or the PID of the C, the ID of the edge above C. So if okay, then we will output the cats.size first, and then for auto as cats we will output s, and then we will output a new line. Otherwise we will simply output -1 and new line, because we can't do it. So now if we go and hit and run it, and copy this, 612. So we got a weird error. Sorry, this. So this is a good example. You can't have anything between the as if part. So we need to put this here. What are any weird errors? Yeah, it's that error. Oh, also one more thing that we forgot here before we correct it. So if someone doesn't have a child anymore, then it will be a new leaf. So when it gets to 0, then we will q.push that parent. So every time someone loses their last child, they will be considered as new leaf. Let's see that here, okay. And let's see, that's the error. Yeah, so we need the s.first here, because we have a pair because of the ID. Right, so let's go ahead and write, see if we have any bleed errors. If not, we will, no we don't, we will take, let's say, the second test case, and we will see if it's correct. So we output -1, then 0, then we output it -1 again. Shouldn't be correct. We take a look at it. So -1, 0. It's not -1. And then let's put this incorrect as well. Oh yeah, because we need to take out from the queue everything that we already used. So here, while queue is not empty, so this example we will put these both strides in the queue, and then when one of them is set to true, we can't actually take out from the queue at that moment, but we will remember that we used it, and if we come across it in the queue, then we will pop it out. So if used b q.top, q.front, sorry, if we use the front value, then we will pop it out, and we will do it in a while cycle. Otherwise, we will break out of the while cycle like this. That way, we can guarantee that we only use it once. And now let's check it again. Oh yeah, so here, if q is empty, then we will need to break out from the outer while cycle as well. So let's go ahead and try it again. So yeah, negative 1, then we have 0. Negative 1 again, which is not correct. Let's see the last one. 2, 3, 4. Yeah, that's correct. Okay, but this example is not correct. So I will go ahead and try to draw that example so we can see when our source isn't correct. So this will be, so we have between 1 and 2, 1 and 3. So this will be 1, this will be 2, this will be 3. So we have an edge between 1 and 2, we have 1 and 3. So we have between, and we also have between 1 and 6. So we have 6 here. So 1 and 2, 1 and 3, 1 and 6. We have between 3 and 4 and 3 and 5. So the correct way is to take this, and then we can take this, but the solution can't find it for some reason. So let's take a look. So increase the chance of B, C. Okay. So maybe I'll go a bit again. Just one test case with this test case, and you can see that it outputs even. So I will just copy this test case and see if we can fix it. So oh yeah, I see the problem. So first it will put in the queue to 2, 4, 5, and 6, and we need the one which is the lowest. So the distance is highest to the so the distance is highest to the root. So we will need a priority queue, and we will also need a distance. So the distance is set back to 0, and here, before we go into the DFS, the distance as the first will be equal to the distance of the parent plus 1. That way we can have the distance, and here we will have a priority queue, actually with pairs of long, long, and long, long. So we will put the distance of I and the I inside of it, and here we will need to call it top, not front, and here we will need it to the second, so the index. So if we sort this based on the first one, and we need the second value here, and also priority queue sort and puts the highest value by default, so we don't need to put the comparison function there, because the default is just fine for us. And here also we need the second, and here if we go down, then we push to the priority queue. We need to choose the distance of PA first with the PA like this, and here as well, distance of PP and PP, and here as well, distance of C and the PC itself. So now let's go ahead and run it. Hopefully I won't miss anything. And good. And now we have the solution. So hopefully it's correct now. And I think I saved it to the number1 file. Now we can see that we got a wrong answer on test case 3. Something is still not good. I think I see the problem, so let's say that we have something like this. So we have this and this and this. Yeah, that's the problem. So I connect this. So when we have this type, but also, so if this doesn't have any other child, then we will take its parent. But if this has another child, then we should set the OK to false, because we can't find. Okay. Actually, can be. Yeah, we can still find someone to it. It's like this, and so if we have something like this, we can do it, because then we can take these 3 and then these 3. But we can't take its parent anymore. So what's important is here, if we already used A or used B, then OK will be false and we break out. So if we try to use something multiple times, because we just allowed it in the example here as well, if used B, C, then we will set the OK to false and we will break out. So hopefully this will solve the problem. I'll just build it, not run it this time, because I'm pretty confident that it will solve it. Now I will come back here and submit the solution again. So what I did is make sure that I can't use the same node multiple times. And now we got accepted. Alright, so now time to go back to the problem F that we left. So unfortunately I cannot figure out the problem with this F problem in time. So that's 6 out of 7 solutions for now. If you enjoyed today's video, make sure to like and subscribe, and see you in the next video.